All right, so before we get going, a couple things off the top. So that Module 9 reading was due before we started class today. We'll start Module 9 today, finish it tomorrow. After tomorrow's class, that Module 9 quiz will pop up. We'll have the participation quiz from today and tomorrow. All of that, as well as the Module 8 quiz and participation quizzes from Module 8 will be due by the end of the day, Thursday, right? Because we have that second exam on Friday. So I'll talk more about that tomorrow and on Thursday. But Thursday we'll be doing review for that exam. Excuse me. And you've got the practice problems and answer keys here. So something else I wanted to mention was Module 5 and 6's quiz. So right here, one of the problems had the wrong, I put up an announcement about it. One of the questions was like 1.25 instead of 1.5 points. So I've got that updated. So your scores should kind of have updated with that to reflect that there was a total of not of 17.75, but 18 points on that quiz. I also put up a little blurb about this test quiz. So most of you this won't apply to because you did the participation quiz from last week that required that lockdown browser. If you didn't do that, you need to make sure the device you're using for the exam Friday has that lockdown browser working. So I put up a test quiz. So even if you did that participation quiz, you can still do this test quiz to make sure whatever device you're using Friday, that browser kind of making sure before Friday that it's working. It's not worth any points. It's just there to kind of make sure we can kind of test to make sure that lockdown browser is going to work. Okay. Other than that, I think that should cover all the kind of housekeeping stuff. I am going to finish up Module 8. In fact, I'll rename these. It shouldn't say like post. It's just going to be Module 8 complete slides. We'll finish up a couple things we didn't talk about yesterday. We'll then jump into Module 9 here today. Other than that, I think that's all the logistics before we hop into material. Are there any questions before we start? Okay, so Module 8. I introduced this idea a little bit, but we were talking about, we have a price change. We come up with this hypothetical budget constraint where we said if we kept the total utility the same, so we can afford the same amount of utility after there was a price decrease in soda here, that movement from point A to point B, same indifference curve, different relative prices, that was going to represent our substitution effect. Movement from B to C, we were having this hypothetical budget constraint, keeping relative prices the same, but allowing us, okay, when there's a price change, it changes real income. So how much more utility can we afford? That movement from B to C was our income effect. What's going to dictate the total effect is the relative size of those two. So we talked about Giffen goods, sometimes the income substitution effect work in opposite directions. What's dictating the size of this substitution effect? Okay. So we said, I kind of gave a little bit of an explanation where we're thinking about things that are pretty close substitutes. So this is like quantity of Pepsi and Coke. To me, it's cola is cola. It's pretty much the same thing. So if the price changes quite a bit of one of those products, we're going to substitute away towards whatever is cheaper. So notice here, if the price of Coke goes down, we're going to see people buy a lot more Coke and a lot less Pepsi if they're close substitutes. So the less, I'll use the extremes to make this point in a second, but the less of a bowed out or bowed inward shape there is to our indifference curve, the larger the substitution effect. That same change in relative prices, if we have a really bowed inward indifference curve, that's going to represent that these are complements, that even when the price of hot dogs goes down, well, I don't really eat hot dogs unless I'm using them with a hot dog bun most often. So yeah, I will buy a few more hot dogs than I was before, but I'm not going to see a reduction in the quantity of hot dog buns by very much because I still, I kind of eat these or have these two things together. I use them at the same time. So we'll think about some extreme examples. So I think I have shoes and then I have like bottles of water here. So I will draw this one out for us. We have those reference slides, but let's think about if I had perfect complements first. Okay. So this was the idea. Let's say I had like left shoes and right shoes for whatever reason. If, this is a good example of a perfect complement. I can't really, I have no use for a right shoe if I don't also have a left shoe, right? So we would think about the indifference curve. I get the same amount of total utility if I have one left shoe and a bunch of right shoes. Well, I can't use these. I can only use each shoe. I have to have one left, one right. So the amount of utility stays the same if I have more of the right shoe, but no more of that left shoe. Okay? So that's going to be true as well. Now, if I want to get to a higher indifference curve, there I would have to have two of each. Right? So we have this kind of weird scenario. Like, let's just start out assuming this was my budget constraint. Okay. Well, the highest indifference curve I can get to, all of these points would be unaffordable, but I can't afford this point on this indifference curve, which is having one of each shoe. If the price of this left shoe, let's say for whatever reason, decreases, right? So I see this shift in my budget constraint. Well, what's the highest indifference curve I can still get to? Well, notice, why would I want two left shoes and one right shoe? It gives me the same amount of utility as having one of each. I'm just spending more money to have this thing that provides me no additional margin utility. So when we have perfect complements, we'll actually see people kind of go back to this kind of kink point, right? Or where the quantities of both the goods are exactly the same. So I can see a price decrease with perfect substitute, complement, sorry. And the quantity that I use of each of these goods actually doesn't change at all. Right? So with perfect complements, there really is no substitution effect. The fact that this good is relatively cheaper now, because I have to use these two goods at the same time, it doesn't impact how much I would buy of each. Right? Now, if I had an income shift, that's a different story. But when we're thinking about that substitution effect, that came from a price change. So with perfect complements, price changes will result in no substitution effect. Right? I can't have two left shoes. Right? That doesn't do me any good. I need one right and one left. Okay. So with perfect complements, we have no substitution effect. All right. So no substitution. Let's think about a scenario. I'll use my bottled water example because, I don't know, it was Aquafina and I don't know, Evian water. I view these two things. Bottled water is all the same to me. So I only care about the price. Right? So it ends up being true if we have perfect substitutes, our indifference curve actually looks like a budget constraint. Why? Because if I have one bottle of Aquafina, 10 bottles of Evian water, I view that the same as having one bottle of Evian, 10 bottles of Aquafina. They're perfect substitutes, right? I don't care what combination I have of both of these. So where would our budget constraint be? Well, we have, multiple indifference curves here, which represent higher amounts of utility, even though these are still perfect substitutes, right? I can afford more as my income goes up. Our budget constraint, let's start out assuming that it exactly matches up with that indifference curve. What would, for perfect substitutes, what would the slope always be? It's a perfect trade-off between the two goods. I'm always willing to give up one of the other good to get one more, one of the y-axis good to get one more of the x-axis good. So we have this weird scenario. Let's say I had a price increase in Aquafina. Well, if I'm only buying Evian water, it doesn't change it. So now I'm down here. If this is my budget constraint, right, as opposed to this initial budget constraint. So on my initial budget constraint, I didn't care what combination I had here. All of them were providing me the same amount of total utility. So with perfect substitutes, we actually don't, we have multiple points that could be the consumer optimum. Okay. If I see this price change, well, what's the highest indifference curve I can still get to? All of these points are now unaffordable. However, I can still get to this indifference curve if I only buy Avion water. So if that slope here was -1, what would that mean? It would mean our relative prices must be the exact same. So when I see a price increase in one of them, what happens if they're perfect substitutes? We buy whichever good has the relatively lower price now. So from a price change here, what happened? It could have been before I was out here, I could see a huge change in how much of that good that experienced a price change someone is seeing. So really large decreases. In fact, this goes to 0. So with perfect substitutes, I get a really large substitution effect. Perfect complements, no substitution effect. Okay. So the extremes, I think, kind of help solidify this idea. But, in practice, we usually don't see perfect substitutes or perfect complements, but we see things that get pretty close to that. So you'll kind of notice here, if I have something that's not bowed very much, right, that's going to look like getting closer to perfect substitutes. Well, there, when I have price changes, that was where we saw a very large substitution effect. If I have an indifference curve that starts to get to look a little bit more like that 90-degree angle indifference curve, now I'm starting to get things that look more like complements, and there my substitution effect is going to be very small. And so that's what we had kind of right here. Something that's bowed inward a lot more, small substitution effect. Something that's really getting closer to that like linear indifference curve with a slope of -1. There I get a very large substitution effect. Okay. All right, and then just to be complete in our conversation, we did all this last class, but this idea of income and substitution effects, we said that some of those would be our total effect. So thinking about these price changes and the decision to buy two different goods, so I went back to pizza soda here. Let's say soda was $4 a can, and at the current optimum, I was choosing to buy 150. Using price changes on this and our indifference curves, we can actually, excuse me, map out every consumer optimum and you can just kind of plot these. So when the price is 4, they're buying 150 cans of soda. Plot that point. If the price were to go down to $2, well, we know that's going to kick our budget constraint out. We now can afford to buy more soda. So the total effect, right, is moving from A to B. So what's the total quantity of soda we buy when the price is $2? Well, maybe here it's like, my animation's a little off, but 350, right? So I plot that point. I would then go through and do that for every single possible price for soda. If I were to plot all those points out, that's basically my demand curve. All the different prices of this x-axis good and all the corresponding quantities of this x-axis good. Okay. Excuse me. Oh, and I didn't want this to be pizza here. I copy and paste this. This should be my price, right? I'm mapping out the different prices, the corresponding quantities of soda. That's where we derive the demand curve from. Now, usually everything in this class, we're going to be looking at like linear demand. In practice, if you were going to go to the next level of economics, you'd see demand actually has some slope to it. For the sake of making the math easier, we're going to just kind of rely on a linear demand curve. But understanding these consumer optimums, how to identify them, where the indifference curve has the same slope as the relative prices, that's really where this combination of prices and quantities comes from that gives us our demand curve. Okay. Any questions on that before we kind of move to module 9? All right. Sorry, my lights switched off on me and it's storm's rolling in, so it's very dark in here if they're not. Usually I can rely on the natural sunlight. So get out of module 8 here. We'll jump into module 9. So module 8 was all about consumer decision making. Module 9 is going to focus on firms or the producers. So we're going to start out with a lot of definitions here today, talking through some things before we can get to ultimately understanding how the firms kind of choose points that maximize their profits. So the first thing we'll talk about is the difference between explicit costs. This is going to be anything that involves like the transaction or the handing over money for. Now, obviously now it's not as much physical, but like this could be through your bank account or whatever it is. So anything that has an actual cost where you're giving someone money in order to have it, that's going to be an explicit cost. So this is for companies, for firms, we're thinking about paying our workers, buying raw materials, the rent we're paying on a building. Those are all explicit costs. Those are all things we're going to hand money over for. Implicit costs are going to be related to something we've already talked about way back in the early module. I think module 1 we even discussed a little bit, which is opportunity costs, or what we'll start calling implicit costs. So implicit costs are going to be things that we are not, benefits we're not getting by whatever our current decision is. So whatever benefits we're foregoing. And we'll go through some examples here in a second. But implicit costs are going to be if I'm making a decision, how am I using my time or my money? What additional benefits, if I use that time or money to do something else, am I not receiving? Okay, or am I foregoing? So, the biggest opportunity cost you think about of time. If I spend more time watching YouTube videos and I'm not working, I could be doing something that's earning me money. The opportunity cost of that time, the implicit cost, is how much money I could be making doing something else with that time. Okay. We also have this idea of opportunity cost. If I have money and I'm, I don't know, buying dumb things. So maybe I'm not dumb things. I guess I shouldn't say that. But like, let's say I am, spending a bunch of money on Starbucks all year. And if I would have taken that same amount of money and put it towards mutual funds, I would have been earning some return on investment. By not putting that money towards mutual funds and by buying Starbucks drinks, I'm actually foregoing the interest I could be making on that money. That's another implicit or opportunity cost. Okay. So our total costs are just going to be the sum of those two things, right? So I've got kind of a little example here. I've got some numbers I'll kind of pop up here. So explicit costs, right? If I think about what's the cost of another year of school. Excuse me. So this was, I think I grabbed this from the actual, I think this was in-state maybe at IU. And I think I looked up out-of-state before class earlier, it was like 40,000. But here, if I add up tuition fees, housing, books, transportation, and this might be a little bit old, but the total explicit cost, these are all things I'm handing money over for, is about $28,000. Right? That's just 1 year of additional schooling. However, my implicit costs, if instead of going to school, I work as a construction worker in Indiana, the average wage I could make over the year would be $40,000. Right? So my total cost would be not just those explicit costs, what I had to hand money over for, but also those implicit costs. Right? So I'll kind of roughly use some of these values to kind of show, should I be going to another year of school or not? Well, really, we're going to take those costs, compare them to the benefits, and see, is there a net gain, right? So let's say, for example, the additional wages I can make going to another year of school in my life was $200,000. Okay? So this is like additional wages. And let's just do I think when I looked it up, it was room and board. It was out of state, tuition, etc., cost $40,000. Right? Well, initially you might look at this and say, well, yeah, I should definitely go to another year of school because the benefit of doing that is way greater than the costs. Or if I take the difference between the two, that's greater than, or I have a net benefit of zero, or greater than zero. So 200,000 minus 40,000 from that additional year, 160,000 would be like my net benefit. It's positive. However, what if I could work as a construction worker? So in my example, well, by going to class, taking my time studying, I'm foregoing, this would be what we call our accounting profits, right? And we'll get to that a little more in a second. Or I'm not factoring in my implicit costs, right? I was just looking at my explicit costs here. If I factor in my implicit costs, I still have that same benefit of 200,000. I'm paying $40,000 tuition, room, and board, but I now have an additional, instead of 50,000, just to make the numbers different so it's clear, maybe if I was working, I could be making 50,000. So my actual kind of net benefit from going to another year of school isn't 160,000. it's only 110. Now it's still positive, so I still should go to another year of school here. But I kind of think about this example. I had a student who's like I like to brag on him. He's in the minor leagues basically of IndyCar racing. So, if he hits it big, he's foregoing a lot more than $50,000 potentially to go to another year of school, right? Or you could think about a weird example like, what if you could get a really huge social media following and generate a lot of money over the course of the year instead of going to school? Let's say the wages that you're foregoing by doing that, excuse me, are 150,000, right? So what I really should be doing, right? Well, I wanted it to switch my decision. Hold on. Not 150. Let's do 180,000, right? Well, if I'm foregoing instead of $50,000, 180,000, what is my net benefit of going to school for one more year? Well, 200,000 additional wages, 40,000 tuition. But now I'm foregoing this 180,000 I can make doing something else that year. Now I end up with what? An actual negative net benefit, which would mean it doesn't make sense to get another year of schooling. Right? So just kind of a little base example. It's not so much a firm example. It kind of is like individual decision making. But we can see that once we factor in these implicit costs, if we only look at explicit costs, it looks like we should for sure go to another year of school. If we factor in the implicit costs, well, if the implicit costs are small, maybe we still should be going to school. If they're relatively large, maybe we shouldn't, right? So firms face a very similar decision-making process, right? So for the firm, what's their main objective? They're going to want to maximize net benefits as well, but for them, we call their net benefits profits. However, we have two different types of profits. One is going to be normal or accounting profits. This is like what you would see in the books, right? So it's going to take all the revenues that you generated minus all the things that you actually had to pay money for. So the building, labor, etc. So you're only looking at explicit costs when we're talking about accounting profits. Economic profits include not only the explicit costs, but all economic costs. So they factor in the implicit costs as well. So you can imagine if I just wanted to rewrite this a little bit, I'd have my total costs were the explicit costs and the implicit costs. So you could imagine a scenario where accounting profits are positive, but if I factor in those implicit costs, potentially my economic profits are actually negative. So the goal of the firm is going to be, just like the individual, maximize your net benefit, or the net benefit including these implicit costs, your economic profits. Okay. So here's kind of a little quick profit example of a firm thinking about accounting versus economic profits. So let's say I've got someone, Stacy, and she wants to open a restaurant, and she's trying to maximize her wealth, right? Or her well-being or her economic profits. What should she do, right? Well, if she can generate $500,000 of revenue over the year, she's got to pay her employees, food, rent, and machinery, right? What would her accounting profits be? Well, we would take her revenues minus all of these costs. She'd be making $100,000 of accounting profits. Sounds pretty good, right? Open the restaurant. However, this isn't factoring in that by owning her own restaurant, what is she not doing? She's not working for someone else. If she was able to work for a different restaurant and she could make $150,000, well, hopefully you can kind of see if I open the restaurant, I'm making $100,000. But if I could work as a chef, I could make 150. What's better, working as a chef? Well, we can actually pick that up if we look at economic profits, because economic profits, we would take those total revenues, we would subtract the total explicit and now the implicit cost by owning our own restaurant would be the $150,000 we're not making somewhere else. So now when we factor the economic profits and we factor in implicit costs, now the kind of net gain to Stacy of owning her own restaurant, or her economic profits, would be negative 50,000. You shouldn't own your own restaurant, right? You should instead work as a chef. Okay. So economic profits are less than zero. So don't choose to do this thing, which is run the restaurant, right? If you're trying to maximize your economic profits, you'd want to work as your chef, right? Making 150 as opposed to only making $100,000. Okay. And then you could do a very similar example, but let's say you can't make near as much money. Like there's not as many restaurants in the area that employ like high quality chefs, so you're only foregoing 50,000. Also, we can think of an additional cost, implicit cost that exists. If I own my own restaurant, not only am I foregoing wages, but that $400,000 I was spending on all of the different things to run my business, if I had just invested it into like a mutual fund, or I think the rate I chose here was just like a CD earning 2.5%. Well, that $400,000 could make me 10,000. So I'm not only foregoing these wages of 50,000, but I'm foregoing these additional return on investment, this interest I could be paid from a mutual fund or some type of financial investment, right? Now, in this case, the economic profits are still positive, so it would still make sense to run your own restaurant, right? Any questions on that idea before we keep moving? I mean, you can imagine, like, when does it start to make more sense to not do your own thing? You could also have, like, if I could get higher return rates, so instead of making 100 or 10,000, if I could make $60,000 a year investing that money, maybe then that would switch my decision as well, right? Just changing that implicit cost. Okay. So another concept we'll talk about, and we'll talk about it right now, and then we'll revisit it next class or tomorrow, is this idea of sunk costs. Okay. So a sunk cost is going to be a cost that no matter what I do moving forward, I'm going to have to pay it, right? So it should be ignored then by my future decisions. If I have to pay the same amount of money, let's say I locked myself into an agreement to pay for rent or location for my business. If I've got to pay that the rest of the year because I signed the contract, no matter if I decide now to open my business or shut it down, I've got to pay that cost no matter what, right? So I shouldn't factor that into my decision. So we'll walk through an example, kind of talk through why. But basically, if it's going to be a cost no matter what I do, what's the marginal cost? It's the change in my costs. Well, this cost won't be changing ever. So when I'm making decisions on the margin, weighing out my marginal benefits and my marginal costs, sunk costs won't play a role. Right? So this is kind of our, American kind of saying maybe, or I don't know, maybe it's not, it doesn't cross culture, but there's no use crying over spilled milk. Once the milk is spilled, doesn't matter if you cry or not, it's not going to make the situation better, right? So our sunk cost example, to walk through maybe an easier way to think about this. Let's say, I think, I forget where it is, north of Bloomington, there's like a movie theater that's outdoors. And let's say they're charging $10 a ticket. So you decide you want to go to the movie. So what must be true? Well, if this is your additional cost and you've decided to go, your marginal benefit must be greater than your marginal cost. So I'm just going to put a marginal benefit value in this example. Let's assume the person would have been willing to pay up to $20. Okay. So their marginal benefit is greater than the marginal cost, 10. All right, I made that decision, but then I look in my wallet and realize I lost the $10 bill that I thought was in there to go to the movie. Now, as long as I still have money in my bank account, should I still go? Well, if I don't go, what is my kind of net gain, right? Well, I would be losing $10. I've lost the $10 bill. If I choose to go, well, my marginal benefit would be 20. I have to buy a ticket, which is 10. So the difference between my marginal benefit and my marginal cost, like the consumer's economic profits, would be $10 there. But I lost this 10, so I'd be back down to 0. But 0 is better than -10, right? Going to the movie, I would have a net benefit of 0. Not going, -10. I'm better off choosing to go to the movie. Okay. All right. So as a lot, decision shouldn't have changed at all. The marginal benefit, that $20, is still the same. The marginal cost is still an additional ticket of $10. That relationship shouldn't have changed at all. Same kind of idea. If I buy the ticket and then I lose it, should I go back and buy another? Well, if I don't go back and buy another, I've lost $10. If I go back and buy another, my marginal cost, I have to spend an additional 10, right? And my marginal benefit is still 20. The marginal benefit is still greater than the marginal cost. So yes, I bought 2 tickets. The total cost is 20. My total benefit's 20. I'd be at kind of a net, gain there of 0. But if I don't go back and buy another, what is my net gain? I've lost the $10 I spent on the first ticket. 0 is better than -10. So same kind of thing is going to apply when we talk about businesses. And they look at the books and they're like, we had a huge loss this past year. Well, that loss is going to be on the books no matter what I do moving forward. So moving forward, I should only be making operation decisions based off of the future marginal benefits and marginal costs. The losses that I've already incurred, those are sunk, right? I've lost that money no matter what I do moving forward, okay? So sunk costs, right, shouldn't factor into our decision making. So what do we say to the sunk cost fallacy? Not today, right? So we don't want to factor sunk costs into our decision making. And as long as we're making decisions using marginal benefits and marginal costs, we shouldn't fall victim to this, okay? Once again, we'll kind of relate this a little bit to what we talk about tomorrow. So switching gears a little bit here, we're now going to start to think about where does a firm's costs come from, okay? So we're going to talk about a difference between firms' long and short run, right? So the long run, every factor of production is going to be variable, or we can change it. So this is like over the next 10 years, I can move to a larger production facility, right? I can invest into better machinery. I can change anything in the long run. However, in the short run, I can't just up and leave the building I'm in if I want to continue my operation tomorrow, right? I'm kind of locked in, maybe to lease agreements. I'm locked into my location, right? You could even think about firms choosing to move their production facilities overseas. Currently, you're locked into wherever you are. You can change it over the next year, the next couple years, but overnight, there's going to be some things that are fixed in the short run. Now, we often think in most examples, and the examples that we'll use, the thing that is always going to be kind of variable we can change still in the short run is labor, right? I can hire and fire workers day by day, okay? So that's the example I'll often use. Now you could think about there are some other forms of capital that we can change pretty quickly. Maybe I have, if I have different machines I'm renting, I can kind of replace them over a week or something like that. But labor is the easiest one to think about in the short run. Day to day, we can change it, okay? So we can hire workers as soon as people apply. So we're going to think about today really focusing on the short run. So in the short run, we can hire different workers, or we can change the quantity of inputs we're using. Our input here is going to be the number of workers. There is some production function where if we have a certain amount of capital, so this is things like machinery, we could also even kind of think about this as we've got land in here. We could complicate this formula to have like where our building is located, or how much we're paying for that location. But really, we primarily think about this production function being, I've got some machinery, some raw materials, some capital. I also have some labor. The labor is using that capital and raw materials to then produce some output, right? Some product, okay? And this product could be, all these goods we typically, I could do, bottles of water, I could do automobiles, whatever it is. It's going to be a function. How many automobiles my production facility can produce is some function of how many workers I'm hiring, okay? And how much capital or machinery I'm giving them. So we're going to use graphs and tables to represent this production function. Now, it simplifies it a little bit. In practice, you could actually look at a functional form here and kind of complicate the math. But for us, we're just going to rely on simple graphs and tables, okay? So the example I'm going to run with today is an example of thinking about like a Chipotle. Right? This is if you're not familiar, I'm sure most people are, especially if you're living in Bloomington. This is like a Mexican restaurant, pretty kind of fast food, kind of fast casual. So they can hire workers, as many workers as they want in the short run. They're kind of locked into whatever capital and whatever building location they have that they need to run this Chipotle. So we'll think about how do different amounts of labor impact how much output they can produce, okay? So what we're going to do is think about, as I hire more workers, what's going to happen to the quantity, and here we'll just choose one product, say burritos, that they can produce. Excuse me. So if I hire 0 workers, I'm not going to get any product, right? No one working behind the counter, I can't sell any burritos. If I hire 1 worker, they can, take the order of someone, make the burrito, sell it. maybe in a day they can do 1,000 different orders, or maybe this is monthly, whatever it is, weekly. So if I hire one worker, this Chipotle can produce 1,000 burritos. If I hire two workers, well, I hired the best worker first, right? So they added what, 1,000 burritos? The second worker, I hired the next best. They can produce 800 burritos, right? So giving me a total of 1,800. And then the third, I would have a total of 2,400, fourth, fifth, etc. So we can map out all of these different combinations of the number of workers and the corresponding amount of output we get. This is what we're going to call our production function. Okay. Once again, this would have a functional form. We're just going to use kind of simple graphs and tables like this. Okay. So here's my production function. If we think about the marginal product, just like we can talk about things like marginal cost, marginal benefits, well, marginal product is how much additional output am I getting when I hire one more worker. So my marginal product of labor, right, is the number of additional burritos I'm getting from hiring one more worker. What would that represent? The slope of my total production function. Right? If this is total production, marginal is like the change in. Well, the change in a function is its slope. Right? So we can kind of think about going from 0 to 1 workers. What was my marginal production? Well, I added 1,000 burritos divided by hiring one more worker. Marginal product of labor was 1,000. That second worker, how much was output changing by? 800 divided by a change in the number of workers was just 1, going from 1 to 2. So there my marginal product was 800. Oh, it was lower. So notice what's true about our production function. If the marginal product of labor is going down, if the marginal product of labor is going down, our total production function is getting flatter. Okay. So anytime we want the marginal anything, it's the change in that thing. So the marginal product, the change in the product, or the change in our output from what are we choosing to change, right? It's the response of our output to a change in the number of workers or the change in labor. Okay. So in our example, we could kind of find the marginal productivity of labor for every worker by simply doing change in the quantity divided of the product divided by the change in the quantity or the number of workers. So 1,000 over 1 is 1,000. 800 over 1 is 800. 600 over 1, 600, so on and so forth. Right? And we said, what do we notice is true about this marginal product of labor? Well, if I'm hiring the best workers first, I'll end up seeing that my marginal product of labor, how much additional burritos each worker is adding, is going down. Right? Representing this was the most effective worker, second most effective, so on and so forth. Okay. Now, usually we don't just have jumps in the quantity of labor of 1. Sometimes the math can be a little bit more difficult. So if I did have instead, like this was 10 workers, it's the same process to find the marginal productivity of labor. I would still look at the change in the quantity of the product divided by the change in the number of workers. So here that would be 1,000 divided by now 10. So the first 10 workers total would produce 1,000 burritos. So I have a marginal product of labor of instead 100. And then what if I want to go from 10 to 20? Well, there my change in output is 800. Number of workers I had to hire 10 additional workers. So 800 over 10 is 80. I would going to continue that process. I still see I've got this decreasing marginal product of labor, even if I don't have jumps, of 1 worker. Okay. Questions on this before we keep moving? Okay. Just another example. I had kind of laying around some old slides. But let's say I had, this farm. I have the bushels of wheat, quantity of labor here. What would be the marginal product of the 5th worker? Well, if I want to hire the 5th worker, I'd have to be going from 4 to 5. So I'm looking at how much does my output change by when I have 4 workers compared to 5 workers now. So the change in my output would be what? 75 minus 64 is 11. Divided by a change in the number of workers of 1, 11 over 1, should give me that marginal product of 11. Now, even if I didn't give you the numbers down here, what should be true about the marginal product of labor, as long as this farm is hiring the best workers first, the marginal productivity of labor of that second worker should be greater than 11. Right? The marginal productivity of labor should be decreasing as I hire more and more workers. So sure enough, if I compute the marginal productivity of labor of that second worker, going from 1 to 2 workers, output is changing by what? 36 minus 19 is 17. So 17 over 1. Sure enough, that marginal productivity of labor of the second worker is greater than that of the fifth. Okay? All right. So I kind of already mentioned, but right, if we looked at that total production function, well, when I was calculating the slope of that total production function, what was I really doing? I was taking the change in the quantity of the product or output, dividing, right, change in Y over change in X. So the change in output over the change in the number of workers, the slope of my production function is really just my marginal productivity of labor. As we hire more workers, we said that marginal productivity of labor is decreasing, right? Or the total production function is becoming flatter. Okay? So the fact that this total production function is becoming flatter, that's representing to us the marginal productivity of labor is decreasing. Okay? So this is going to be the idea of the law of diminishing returns. Okay? When I first start hiring workers, right, I've hired the most effective first, then the next most, and so the additional output each worker is adding as I hire more workers is going to be going down. However, I'm going to throw a small caveat into that now. If I think about my Chipotle example, maybe initially that first worker, I hire them, they've got to, be behind the counter, they've got to take the order, build a burrito, run the register, go all the way back to the very beginning of the line, get the next customer, do every part of the production process, and then they go, oh, got to go, restart, I don't know, the meat cooking in the back. Well, if I hire a second worker, one person can just focus on taking the order, building the burrito. One person is just maybe focusing on running the cash register and then, handling the meat in the back or whatever. So if I hire initially more workers, they can start to specialize, right? They're not doing as many things and they can get really good at one specific thing. So when I first start hiring more workers, one of them gets really good at building burritos, one of them gets really good at running the cash register. They're even more effective now than they were when they were the only worker there. So if that's the case, the marginal productivity of labor of adding that second worker, because it influences the productivity of that first worker as well, if we have gains from specialization, our marginal productivity of labor could actually be increasing initially. Okay? Now, eventually, once we've exhausted all those gains from specialization, well, now we just have additional workers, and every worker we're hiring, they're less and less qualified, or they're lower and lower quality than the previous ones. So eventually, diminishing returns to our marginal productive labor will take over, and we'll end up seeing that's really what we're going to focus on, because as long as my workers are becoming more, adding more marginal product than before, they're becoming more effective when I have specialization, we know we're going to keep hiring more. So if we're interested in, well, what's the last worker we choose to hire? Well, we know that's going to be when they start to become less and less effective. And then at some point, they'll be so, so unproductive, we'll stop hiring more workers, right? So generally, we're only concerned with this diminishing portion, but we are going to kind of always keep in the back of our mind, we do have this initial gains from specialization, and we'll see how this influences eventually our cost curve, okay? So I'm writing this out, or kind of drawing out a general version of this. If initially, when I'm hiring more workers, I see that the marginal productivity of labor is increasing, this range of workers, we would say we're experiencing gains from specialization. Each additional worker I hire, the additional output they're adding is more and more. As soon as the marginal productivity of labor starts to decrease, we would say we're on the diminishing returns portion of our marginal productivity of labor curve. Okay. So, typically we think about it's going down. If it ever did get negative, right? Well, for sure, we know we're not going to hire those workers because they're actually decreasing from our output. That wouldn't make any sense at all. Now, even though it's positive here, even though they're adding some units, if it's costing me more per unit than what they're adding, I might not choose to hire this many workers. So this is, somewhere in this range is going to be where we stop hiring people, right? If it ever becomes negative, we know we aren't going to end up that low, because then we would just be decreasing our production, right? So that would be the idea of like too many cooks in the kitchen, right? If our total production function ever started to go down, well, we definitely don't want to hire more cooks than this. This is like the Chipotle example. I've got 10 workers, one of them is just standing around doing nothing, getting in the way, actually detracting from the effectiveness of all my other workers. So too many cooks in the kitchen idea. Okay. Where are we at in time? Okay. So I want to talk a little bit about this relationship of the average productivity of labor. Well, did I skip something here? No, I've got it in my next slide. I was going to say, I thought this was coming up. Okay. So the average productivity of labor, the marginal product was the additional output added per worker. The average product of labor is just what the average per worker is. So how do we find an average? We take the total. Right? If you're thinking about a number, you add them up, divide by the number of numbers you have. So here we're adding up the output of every worker, dividing it by the total number of workers that we have. Okay. So what's going to end up being true is if the marginal productivity of labor is above the average, our new average will be higher. And I'll give you something I think that'll help with this in just a second, but for now, stay with me. If the marginal productivity of labor is less than the average, the old average, our new average will be lower. And if they're the exact same, the average won't change. So I just want to kind of give you some numbers to prove this to you, but then I'll give you some slightly different example as well. So let's say I've got that same example, but I changed things around a little bit here, where going from 0 to 1 workers, my marginal productivity of labor, I'm adding 800 units. Change in labor is 1, so the marginal productivity of labor is 800. The average would be 800 divided by 1, or 800. Now, when I hire the second worker, what is the additional output from that one additional worker? Well, I'm going from 800 to 1800, so they're adding 1,000. Notice what must be going on going from 1 worker to 2. Well, if the marginal productivity of labor is going up, I must have gains from specialization. So when I have gains from specialization, right, and this forces this marginal productivity of labor, it's above the old average, right? 1,000 is greater than 800. At that second worker, what is my average product of labor? 1,800 over 2, 900. So when the marginal product of labor is bigger than the old average, my new average is higher. Now, excuse me, if I add the third worker, what are the additional output they're adding? Going from 1,800 to 2,400, so 600 over change in labor of 1. The marginal productivity of labor has now fallen to 600. So I'm now on the diminishing returns portion of the marginal product of labor curve. My marginal product of labor is below the old average. So what ends up being true about my new average? Well, 2,400 over 3 is 800. My new average is now going to be lower. And my marginal product here is below the old average. So my new average, 2,800 over 4, is even lower, right? Et cetera, et cetera. So this is just kind of a general kind of grab. I'm going to draw one out that I think will help solidify this even a little bit more. So I'll give you an example, and then I'll do the graph. That might help you think about this a little bit differently. So this idea of the marginal product of labor and the average product of labor relationship, let's say my current average quiz score is 15 out of 18. Okay. If I get an 18 on this next quiz, so this was like my current average. So what we're on module, this will be module, 9. Well, we'll say the module 8 quiz if you haven't done it yet. If you do better on the module 8 quiz than your previous average, what has to be true about your new average? Well, you're going to be adding in a value to the numerator that's greater than the old average. So the new average has to be above 15, right? And then if you do worse on that module 8 quiz, what would have to be true about your new average? Well, in that numerator, you're now adding a number that's below the old average. Your new average has to be lower, right? So you can kind of think about It's the same thing going on with the marginal productivity of labor. When we're comparing that marginal product to the average product, it's just like you're thinking about what is my current grade in a specific, current quiz score. If I do better on this next quiz, I'm going to pull up my average quiz score. If I do worse on the quiz, that's going to pull down my quiz score. Doing better or worse on the quiz, this is like our marginal productivity of labor, and this is like our average productivity of labor. Okay? So what we can think about to make this a little bit more continuous than like the table I was showing you on the slides is if I've got the quantity of labor, and here I've got my just quantity of the output of the product, we said, here's my marginal productivity of labor curve. I might have some gains from specialization. I drew this pretty extreme, but it's okay. What's going to be true is that in this range here, where the marginal productivity of labor is above the average, right? That's true for every quantity in this range. What's happening to my average productivity of labor? It is increasing. In this range, the marginal productivity of labor is actually below the average. So what's happening to my average productivity of labor in this range? It's going down. Okay? So this relationship between average and marginal will always hold. Okay? And it's really the mathematics of it, right? You could, like I said, you're adding a number into the numerator. If it's below the old average, your new average has to be lower, and vice versa. Okay? Excuse me. All right. So with this idea in mind, we've got, I want to save enough time there. Where are we at? Want to make sure we get to marginal cost. So I'm going to start this discussion, and then we'll look at the participation quiz here in a second. So let's go back to our Chipotle example and think about if the building we're using, let's say we pay $1,000 per month in rent. This is like we'll call a fixed cost. It's something we can't change in the short run. And that every worker we're hiring now, we're going to try to convert how many workers we're hiring and the corresponding output to what the total cost will be. Well, each worker is going to cost us $2,000. So I can go back to my example and say, okay, here's my number of workers. Here's the number of burritos. If I wanted to, I could kind of add in my marginal productivity of labor curve. I'll actually do this for us here in a second. But the cost of the building, it doesn't matter if I produce no burritos or 3,000, it's always that same $1,000. Now the cost of labor, if I want 1,000 burritos, I've got to hire one worker. My cost would be 2,000. If I want to increase my output to 1,800, I have to hire a second worker. My total cost would be 4,000. Right? So my labor costs, my building costs, I'd add those up. I could get my total costs. Okay. So behind, all of these different output levels are going to have a corresponding cost. And that's because to get more output, I've got to hire more workers. And that's going to be increasing my costs here. Okay. Now, if I'm thinking about my total cost curve, unlike my total production curve, when I produce more, it's going to cost me more money. I have to pay, I have to buy more work, hire more workers to produce more. So my cost curve is actually increasing. And what we'll notice here is if I were to calculate the slope of my cost curve, what would that represent? Well, that would be the change in the y-axis, so the change in my total cost, divided by a change in what's on the x-axis, a change in the quantity, change in my total cost divided by the change in quantity, that's just my marginal cost. Okay, so knowing how much each worker is going to cost me, I can determine my total cost, and then the change in those total costs divided by the change in quantity, right? That would give me my marginal costs. Okay, so back to our example, how would I calculate marginal costs here? I'd look at my total costs, change going from 0 to 1,000 burritos, $2,000 was the change in my total cost, change in the quantity of 1,000, marginal cost of 2. If I want to go from 1,000 to 1,800, change in the total cost, 2,000, change in quantity, 800. So notice as I hire each worker, the change in my total cost is always the same, right? We're in this world where we're kind of assuming that each worker, right, when we're hiring them in this labor market, is working for the same equilibrium wage. So as I hire more workers, what's happening though to the number of additional burritos I get? Well, we said the marginal productivity of labor, it was decreasing. So it's the same change in my total cost, but now I'm getting fewer additional burritos. Each burrito is costing me a slightly higher amount. So as I want to produce more and more, I have to hire more workers that are less effective. Each worker is costing me the same equilibrium wage, so my marginal costs are increasing. Which if we go back to our total cost curve, what's happening to the slope? Well, the slope is the change in total cost over the change in the quantity, or that the slope is our marginal cost. My marginal cost or the slope is increasing, right? Which we can see here from the numerical example. Okay. All right. So similar kind of idea, right? We had that total cost curve. And I just said if we mapped out the marginal costs, my marginal costs are increasing. Kind of the reverse of the marginal productivity of labor, right? So we'll come back to this if we have time. I want to look at, well, I want to look at the participation quiz, and then I'll kind of try to tie it together, the marginal productivity of labor and the average marginal costs, and how kind of show you a different look of how those are related. So we'll take a little bit of a step back here for the first few questions, but then we'll kind of get back to this idea of marginal costs and the marginal productivity of labor, if this quiz will load for me. What?
Esther, mine's not working either.
Okay, let's see.
So there's a problem with the assessment.
Well, great. So, I know this was working earlier because I checked it. Let me try something here real quick. I can at least give you the answer. Oh, I wonder if it's like the internet connection or something here. All right, so let me just get rid of this here real quick. I know the one worked for my earlier section, so we'll copy that one over and see if we can circumvent the issue that way. I wonder if there's an issue copying it over for some reason. All right, so it might take a second for it to show up here. Let me see if I can now add this, see if it pops up. It might not. Yeah, we'll have to wait a second. So as we're waiting, I'll kind of revisit what I know the first few questions are about. So let's say I'm thinking about I own an office space, okay? And the rent goes up by $500. So even though I'm not renting it, if I were to rent out the office space that I own, I could be making an additional $500, okay? So if I continue to operate my business out of that office space and I don't rent it to someone else, what would be my explicit cost, right? So we'll try, see if this one's working now.
Yeah, it's not working for me
Something
either.
must be bugged on Canvas then, because it definitely should copy over when I do that. Let me try unpublishing it. Let me see if I can see it behind the scenes. If not, I will. Okay. So I will get this fixed after class. If nothing else, I can manually rebuild the quiz that I have sitting there in the other section. But I'll work through the questions. So this is what you will see when I get that quiz posted. So for those of you who are here live, that way you're still benefiting. As soon as I get that up, you'll have what the correct answers should be. unless this one doesn't work also, and then maybe it's just a Canvas issue right now. No? Okay. Yeah, I'll make sure I'll get that so that it's working. I'm not sure why. Once again, copying it over, it's working in this section, but not ours. Maybe there's a technical issue I might have to send an email about. So if the rental space goes up by $500 a month and I own the space, we said, well, I'm not paying myself the rent. So my accounting profits or my explicit costs haven't actually changed at all, right? So my accounting profits wouldn't change. However, if I'm owning the space and I could charge someone $500 by running my business out of this space, I'm not charging someone else rent on it. I'm foregoing that $500 a month. That would be an implicit cost to me. So when I factor that in, my economic profits would actually go down. Right? So if I own the space, yeah, my explicit costs don't change when the average rent in my town goes up, but my implicit costs do. So you'll kind of see companies, sometimes when the space they're operating in, if they could be renting it out to someone else, what do? They'll move to a different location, right? If they own the building, run their business out of somewhere else, and then rent their previous location or kind of lease to somebody else. Okay? So there we're thinking about if I own it, that's not going to be an explicit cost. It's an implicit cost. Now, if I'm renting the building, well, there when rent goes up by $500, that's an explicit cost to me. So explicit costs are factored in both to accounting and economic profits. Okay. So my accounting and economic profits, if I am renting the building, I don't own it, there they would both decrease when the rent goes up. Okay. So this is the idea of accounting versus economic profits. The next question we're going to look at here, and just to make this a little bit more appealing, so we already kind of talked through these, and also maybe just to make sure everyone gets to the correct answers since this quiz isn't currently sitting in our Canvas page. So the first one we had, there was no change in accounting profits, a decrease in economic profits. Second one, it was going to be a decrease in both. Let's say instead I give you the total output and the corresponding number of workers, and that each worker costs $500. What is the marginal productivity of labor of that 200th unit? Well, if I want to get a quantity of 200, right? What was the marginal productivity of that sixth worker? Well, the change in output was $100, or sorry, $100 was 100, 200 minus 100. The change in the number of workers was 2, right? So 100 divided by 2, that marginal product, when I want that 200th unit, the marginal product of my labor would be 50, right? So we know it's going to be 50. What are the firm's marginal costs at that 200th unit? So I can actually think about this. If I want to get to that 200th unit, I have to go from this quantity of 100 to 200. How many more workers did I have to hire? I had to hire 2 additional workers. If each worker cost me 500, what was kind of the change in the total cost there? Well, I was hiring 2 more workers, each cost 500, so 1,000, divided by a change in quantity of 100, so 1,000 over 100, my marginal cost would be 10. Right? Now, the question actually asks not what is the value of your marginal costs. In fact, you could think about it this way. So I will just write these values down for us. Oh, there we go. So if we had 0, 100, 200, 300, 400, and then I had the number of workers here was 0, 4, 6, 9, 14, right? I could actually calculate my total costs, right? So if I wanted to do that, if each worker cost 500, total cost here is 0. 4 times 500 would be what? 2,000. 6 times 500 would be 3,000. 500, so 4,500. 14 times 500 would be what? 7,000. Okay. So I could actually come up with a column and find the marginal productivity of labor here. So notice if I'm going from 0 to 4 workers, what was the marginal productivity of labor? Remember, that's the change in output over a change in the number of workers. So here 100 over 4 would be what? 25. Change in output here is 100 over 2, so 50. 100 over 3, 33.33. Here what? 100 over 5, right? So now I'm down to 20. Okay. So notice what was true in this range here. Well, my marginal productivity of labor was increasing. Okay. So what should end up being true is when my marginal productivity of labor is increasing, my marginal costs are actually going down. So if I calculate my marginal costs here, going from 0 to 100, the change in the total cost was 2,000. So 2,000 divided by the change in output. So marginal cost was just the change in total cost over change in the quantity of the product. So 2,000 divided by 100 is what? 2. Right? Then what's the change in total cost? That was 1,000 divided by, wait, am I looking at this right? What did I do? I did math wrong here, didn't I? No. Yeah. So my change in the total cost was 1,000 divided by change in output here would be 1. Change in total cost 1,500 divided by change in output 1.5. Change here would be what? 2,500 divided by 100. I'm back at 2.5. So notice when my marginal productivity of labor was increasing, my marginal costs were decreasing. So when I've got gains from specialization, that's what my marginal product of labor going up means. I actually have decreasing marginal costs. Now, as soon as I start to see my marginal productivity of labor decrease, what's happening to my marginal cost there? Well, now they are increasing. Okay. So just to kind of answer the questions, we said that marginal product of the 200th unit was 50. And at that 200th unit of output, we were going what? Our marginal costs were actually decreasing, right? Going from 2 to 1. Okay. And then if we have the same kind of setup, what's the marginal cost of the 400th unit? Well, we actually calculated that already. We said that was 2.5. Right? So that was that 400th unit. We calculated that change in total cost divided by the change in quantity was 2.5. Okay. All right. So with that idea in mind, I'm going to, oh, actually we can stay right here. I want to do one more thing before we stop. So hopefully you'll have any questions over any of the answers on that quiz before we kind of get out of it there. So it was 50 and then decreasing and then 2.5. And that, oh, not 2.5. Oh, no one called me out. Okay, what did I do wrong on all these? 1,000 overall. This should actually be 20, 10, 15, 25. These weren't jumps of 10. These were jumps of 100. Sorry about that. Surprised no one called me out. So my marginal cost there should have been not 2, 1, 50, it should have been 2, 10, 15, and 25. Okay. So I guess it's a good thing the quiz wasn't available there. Now we know that last one is not 2.5, right? It's 25. Okay. Going through that too quick. So I want to point out one more thing about this idea of the marginal product of labor and the marginal costs, right? So I was kind of showing you here, and the same principle applies, right? Doesn't matter. We had the decimal moved one place. But if my marginal productivity of labor, so a graph, so this is like the number of workers here, quantity of labor. And here was like our output, our quantity. We said my marginal productivity of labor, initially, I might have gains from specialization where my marginal productivity of labor is increasing. Eventually, we'll exhaust all those gains from specialization. We're just hiring less and less efficient workers. So in this range here, my marginal productivity of labor is decreasing. Now we saw from that little simple kind of table example with some numbers there, that if I wanted to then think about the firm's costs, well, when my workers were becoming more effective, if I have to pay each worker the same wage, I'm paying the same amount, but I'm getting even more output. So like my cost per unit is actually going down, right? Or the kind of additional cost per unit is going to be going down. So when my marginal productivity of labor is increasing, my marginal costs in this range are actually decreasing. So anytime we have gains from specialization at all of those different output levels, so this isn't the same, right? Even though I'm stacking these graphs, this isn't going to be the same quantity. This is the number of workers, but I could like flip this down here. So for every quantity, like in this range, that's going to be where my marginal costs are decreasing. For every quantity kind of workers past this point, what's going to be happening to my marginal cost as I want to produce more and more? Well, there, and this isn't technically the quantity because we're graphing out the marginal productivity labor. It's just in terms of the number of units, right? So once I start to have diminishing returns to labor, now I'm paying each worker the same amount, but I'm getting less and less output. My additional cost per unit are now going up, right? So when I've got gains from specialization, my marginal productivity labor is going up, my marginal costs will actually be going down. Anytime I've got diminishing marginal productivity of labor, well, there I'm spending the same amount per worker, but I'm getting even less output each worker I hire. Excuse me, my cost per unit, you can think of it that way, my marginal costs are going up. Okay, so gains from specialization, the firm is lowering their additional costs. Diminishing returns to labor, the firm will start to see its marginal costs increase. Okay. All right. So we talked about marginal costs here. I just wanted to point one more thing out before we keep moving. So we had this example where we calculated the marginal cost. I could graph those to get this. What must be true then for this example? What is always true about the marginal productivity of labor? If the marginal costs are always increasing, that must mean the marginal productivity of labor is always decreasing, which that was our original example one. We only had diminishing marginal productive labor. Now, I also want to make a point here when I'm calculating marginal cost. So we'll start to think about this idea of sunk costs next class a little bit harder. But if I go back, what was the change in my total cost here? 2,000. What was the change here? 2,000. If we go back here, remember, the part of total cost that was changing was only coming from the fact that we were hiring more workers. So I could actually use the change in the cost of labor to calculate my marginal cost, and it would be the exact same values. That cost of the building, it was $1,000 no matter what I chose to do. What does that sound like? A sunk cost. Sunk costs really don't get fat, even though they're added into that total cost. When we calculate things on the margin, 1,000 minus 1,000 is just 0. So there is no change in total cost coming from these sunk costs, or these what we call fixed costs. The only change in total cost is going to be from the thing that we're changing, which was labor. So there, our marginal costs, right? We make decisions on the margin, was coming just from the fact that we were hiring more workers. Okay. So to set us up for next class, right? Thinking about what we'll be talking about, we now have a little bit more of an idea of, okay, to get more output, we have to hire more workers. When we hire more workers, we have to pay more money. We have these ideas of our, increasing marginal costs. What do I want to start to do if I want to maximize my economic profits? Well, I've got my total costs, which were implicit and explicit costs. I then calculated my marginal cost from that. If the additional cost for every unit I'm producing is below however much money I can make selling it, well, that's a good thing. How much money is a firm making? Whatever number of units that they're selling times the price they can sell it for. So we'll start to think about, as long as that price I can sell the product for is above whatever it cost me to produce it, I'm going to want to produce that unit, or I'm going to want to hire a worker to produce up to that, whatever unit that equates to. Okay. So we'll start to think about if the value of a worker, of what they're adding in terms of the product times the price, if that's greater than the additional cost per worker, then we want to hire that worker. Okay. So I've already drew that graph for you, connecting marginal product of labor to marginal costs, those different ranges. We'll kind of focus more next class on making this distinction between fixed, variable, and total cost, thinking about how we calculate those given a cost table or a cost graph. So we should have plenty of time tomorrow. And it looks like we have quite a few slides left, but a lot of these at the end we'll go through really quickly. There's just some visual examples of the last topic that we'll talk about. So we'll pick back up here talking about costs tomorrow. I will get that quiz. Once again, I'll probably just have to type it out by hand, so it might take me 10-15 minutes, but I will get that up on Canvas as soon as I get back to my office. Okay. So I'm going to end the recording there.